Water is a unique chemical. Without it, life as we know it cannot exist. At temperatures of between 0 and 100 degrees Celsius, it is a colourless, odourless liquid. It is the one substance that exists in all three phases on Earth. Water is a highly effective solvent, and its interaction with other chemicals enables complex life forms like us to live. Life in any form is unlikely to have evolved on Earth without it. It has a high surface tension, which means it can form droplets and move upwards by capillary action. Pure water at a temperature of 4 degrees Celsius has a density of 1 gram per cubic centimetre. As it cools below 4 degrees, its density decreases. That's why ice floats in water. Its density decreases because water expands when it freezes. The same mass occupies more volume. Water's density also decreases as it warms above 4 degrees Celsius, so liquid water also expands in volume as it gets warmer. Liquid water is transparent to light, so plant life can exist in and underneath the water on the Earth's surface. Most water on Earth is found in seas and oceans. More than 2/3 of the fresh water on Earth is held in glaciers and ice caps, and the vast majority of the planet's fresh surface water is held in lakes. Water is also present in the atmosphere. It moves between the atmosphere and the surface in a cycle. At first glance, water appears a very simple chemical, but it has some remarkable properties, and it is unique in some ways because of its molecular structure and composition. A water molecule forms when 2 hydrogen atoms join 1 oxygen atom, forming 2 covalent bonds where electrons are shared. Its chemical formula is the first one everybody learns, H2O. Often the phase is indicated with the formula. A water molecule has a bent triangular shape. Water in large volumes can appear blue, which is because of the absorption of red and infrared light. This is due to the vibration of bonds between the oxygen and hydrogen atoms. This is unique to water and demonstrates the relationship between its chemical structure and properties. Water is a polar molecule. The pairs of electrons shared by the hydrogen atoms in a water molecule are actually more attracted to the oxygen atom with its 8 protons than to the hydrogen atoms with their 1 each. The hydrogen end of the molecule is weakly positive and the oxygen end is weakly negative. This property of an atom within a molecule is known as electronegativity. This table shows electronegativity values for various atoms relative to fluorine. Oxygen is 3.44, while hydrogen is 2.20. The polar nature of water's molecular structure means there are strong bonds between water molecules. They are held together by hydrogen bonds. The weakly or partially positive hydrogen end of one molecule is attracted to the weakly or partially negative oxygen of another molecule, and hydrogen bonds form. This structural characteristic of water explains why its surface tension is so high and how liquid water is able to spread like a film, pool into droplets, and remain in droplets on vertical surfaces like a window, despite the downward pull of gravity.